Everybody say hi, hey, Jalen.
Hi, Jalen.
Blah, 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 blah. Okay, we have section 1.5. There's the homework assignment for this, and I'm going to start this section by looking at like a diagram. So we have two lines that are intersecting each other, and what I've gone ahead and done is I've labeled those angles as angle 1, angle 2, angle 3, angle 4. Do you see that? Okay, when they label the angles with numbers, it makes it really nice so you don't have to like label him with letters. Like for example, angle 2, we could call another name. What's another name for angle 2 up there? AEC, right? Or CEA. Okay, this morning Kyle said, oh, let's rearrange the letters and call him angle ACE. So he's ACE. Can we do that? No, because the vertex has to be the middle letter, right? E would have to go in the middle, okay? So we couldn't call him ACE. We have to call him AEC, right? Or CEA. So there's that. But naming him with numbers makes it really nice so that we can, just call him one thing and not have to have 3 letters, okay? All right, there's a lot of vocabulary in this section, and the sooner you learn these terms, the easier it will be for you, okay? So the first word that we have is adjacent, okay? So, and we're talking about angles that are adjacent, okay? 2 things that are adjacent, and adjacent means right next to, okay? In other words, they're angles that are going to share one side and a vertex. Okay, so they're going to share a side and they're going to share a center point. That's what adjacent looks like, okay? They're going to share one side and they're going to share a vertex, okay? So give me 2 angles up there that share a side and a vertex.
Angle 3 and angle 4.
Angle 3 and angle 4, yep. They share, angle 3 and angle 4 share this side, that squiggly one that I just made. 3 and 4 share that guy, okay? And there's a bunch of combinations. Give me an example of 2 that do not share.
1 and 3.
Right? Like 1 and 3. Angle 1 and angle 3 would not be adjacent, right? They're across from each other, but they don't share a side, right? Okay, they're not like right next to each other. They don't have a common side. Does that make sense?
Yeah.
Okay, that's adjacent, all right? Then another term that we will have is something called a linear pair, okay? And a linear pair is 2 angles that make a straight line. 2 angles make straight line. Okay, so we're going to do an example of this. Let's say the straight line that I'm talking about is this one going across here, right? Okay, if that's the case, then this angle right here, which is called angle 1, and angle 2, those are going to together make a straight line. Does that make sense? Right? Angle 1 and angle 2 make a straight line. So angle 1 and angle 2 make a straight line. Make sense? Something like that, right? Let's even get into some stuff here. There we go. Angle 1 and angle 2. That's a linear pair. Do I have more than 1 and 2 as a linear pair?
3 and 4.
3 and 4 would be a linear pair, right? What else would be a linear pair?
1 and 4.
Right? I could go by this line instead, and I could say 1 and 4, this angle and this angle make a straight line, right? Or I could say 2 and 3 make a straight line. So there's like 4 combinations that I could have for a linear pair, right? Okay. All right, let's go down to this box. And those are the first 2 things that they have going on here. So adjacent angles. These guys are adjacent, right? They are right next to. They are sharing this side and they have the same vertex. So angle 1 and angle 2 are adjacent. They are adjacent, but not what? But they're not a linear pair, right? Because they do not form a straight line. They would have to make a straight line all the way across in order to be a linear pair, okay? What about this example, angle 1 and angle 2? Here, are they adjacent?
Yes.
Are they right next to each other? Which side are they sharing? Which side do they share?
I don't know how to label it.
The bottom right one. That's the side that they share, right? Does that make sense? Are they a linear pair? No, so I'm going to say that they're adjacent, but not a linear pair also. Okay, same situation. All right. Okay, then they give us some non-examples. I don't like this non-example because I don't understand. Oh, I think I do understand this non-example. ABC is this angle right here, so it's overall this angle, right? And then angle 3, they're saying those are not adjacent. Why not?
Because 3 is inside inside.
Yeah, 3 is like an angle inside of the big angle, right? So that's not adjacent, right? 1 is inside of the other one, so that's not a thing, okay? Then they're talking about angle 3 in relationship to ABC over here. Those are not adjacent, right? Okay? And this morning they asked, well, like, they kind of share a side, right? Like this thing right here, they share a side, right? Okay, but they don't have the same vertex, right? This one, B is the vertex here, this point is the vertex. So Jake Hodson then was like, okay, well, what happens if this was angle 3 and let's call this guy like angle 4? Then are they adjacent? Yes, right? Because they're sharing this side. And they're also
The
a linear pair, right? Because they're making this straight line across. So 3 and 4 would be adjacent and a linear pair. Does that make sense? Okay. All right, so let's go down to linear pair right here. This is an example of a linear pair, 1 and 2. These are also, this is a linear pair, and they are adjacent, right? Are they right next to each other, sharing a vertex and a side? Yeah? Angle 1 and angle 2, linear pair and adjacent. Okay, non-examples. Are all linear pairs going to be adjacent? Yes. Yeah, if they're forming a straight line, and the linear pair has to form a straight line and be right next to each other. So yes, all linear pairs are adjacent, but not all adjacent are linear pairs. It doesn't work the other way around. Good observation. All right, so let's go over to this one. Let's talk about like these two angles right here, this angle and this angle. Okay, those two guys, those are adjacent, right? They're sharing this side, but they're not making a linear pair because this bottom would have to be a straight line across, and it's not. Does that make sense? We understand how this works? Okay. All right. And then the last thing that we have is something called vertical angles. Okay. We know that the word vertical means up and down, but in this case, it's kind of meaning up and down a little bit-ish. All right. So vertical angles. This one's the most important of the 3. So really listen to this one. All right. Vertical angles. You have to have, must have 2 intersecting lines. Like straight lines, 2 intersecting straight lines, okay? So like in this example, I have 2 intersecting straight lines. They are this one here and this one here, okay? They have to intersect like that, okay? Vertical angles are just the ones that are across from each other, okay? So like 1 and 2 are vertical angles, right? And they kind of like represent vertical angles because vertical means up and down, right? Yeah? But 3 and 4 are also vertical angles, even though they're like horizontal, right? So those 2 are vertical angles as well, right? Even though they're not vertical. But if I would rotate this, this would be up and down from each other. Does that make sense? Okay. Vertical angles just like that, right? Okay. Vertical angles kind of form a V, I always think. Like there's a V on the top and a V on the bottom. Like they're making 2 V's connecting like this. I don't know. Anyway, so there's that. All right. I'm going to cheat, and one of the first concepts that we learn on the backside is that, let's say, for example, angle 1 up here is 130 degrees, let's say. Okay? Is there some other things that I maybe know? 2, what will 2 have to be? 130 also. Can you see that? Vertical angles will have exactly the same measure. So if the top one's 130, the bottom also has to be 130, right? Okay, what can we figure out what 3 and 4 have to be then? Yeah. Right? If we look at this as being a straight line, angle 1 and angle 4 are a linear pair, right? They're making 180 degrees. So what does angle 4 have to be? 50, but then that means that angle 3 has to be 50 as well, right? Okay, so we can figure those out if we're given 2 straight lines. Okay, I really like their non-example over here because do you see what's wrong with that? Okay, like this is a straight line, great, but this one is like a bent line, right? So we can obviously see that this angle right here is not the same as this one, right? Those are not going to be the same measure.
What if you did it the other way around, like ADDC? Like, would that still work?
Like this one right here and this one? Is that what you're saying? No. What?
Oh, never mind.
What are you saying?
Never mind. I get it now.
Okay. Okay. So yes, there are no vertical angles in this because it's not 2 completely straight intersecting lines. One of them is bent, so that does not work. Non-vertical angles, right? Okay. All right. They give us a diagram down here of these like little cheerleaders. I don't know if you can see this, but like this point right here is O down in that bottom corner, and this guy is called L. And the rest of them is like this is N, this is M, J is the middle, H is the top here, and K is this top point here, right? Do you see those? Okay? All right, so we're going to identify some things. And the key to this is that ABC are going to have multiple answers. We're just going to provide like one of the answers, right? So a lot of these questions will have multiple answers that you could choose. Okay, this is another section that's really hard for me to grade because there are more than one right answer, right? Name two acute. Acute means less than 90 degrees. Adjacent means right next to. Okay, two acute adjacent angles. So two angles that are right next to each other that are small angles. Okay? OJN.
OJN and NJN.
Sure, OJN and NJM. You want to do that? NJM? Okay, let's do that. All right, there's multiple right answers. So angle OJN and angle NJM. Those are smaller than 90 and they're right next to each other. They share a side, right? We see that they share a side. Okay. All right, let's go to the next one. Name two obtuse vertical angles. Okay, so before we identify the vertical angles, let's identify the straight lines that are going through here. So what's one of the straight lines? HJM or just HM, right? We just name a line with two things. And the other one is KN. Those are my two straight lines. Okay, now I can look at vertical angles, right? I only have two options. I have these this top one and this bottom one, right? Those are vertical. But then I also have this side and this side, right, that are vertical. Okay, those are my only options that I have, right? Okay, so I want the obtuse ones. I want the ones on the sides, right? Okay, so what is the one on the left side? HJN.
And then KJN.
HJN and angle KJM. Yeah, that's those two. So that one only has one answer that we could have done, right? Okay. All right, and the last one is naming a linear pair. So I'm going to leave my two lines up there, and let's focus on one of the lines, okay? So let's maybe talk about just like this line right here, okay? Let's talk about that line right there. I need two angles that are making that line.
45.
What?
HJO
Or the actual.
OJM.
Okay, so this is what Angel said. If we're looking at that line right there, she says HJO, which is this guy right here, and OJM. Those two guys, the pink one and the purple one. Do you see that? Those two are making up this straight line right here. HJO and OJM. Does that make sense? Do we see that? Okay. There are many different answers that we could have done. That's just one of them, right? Okay, good. Happy with that? All right, on the back side, the very, very first thing that we talk about, these two guys, this one here at the top and this one here at the bottom, those are called
Go away.
vertical angles. Those are called vertical angles. And then this guy over here and this guy over here are also vertical angles. But we've talked about this. We said that like if this is 110 degrees, then the bottom one will also be 110 degrees, right? This says vertical angles are congruent. They are exactly the same measure, right? If they're across from each other from two straight lines, they are exactly the same measure, right? Good? Okay, next thing is complementary and supplementary, and I'm going to do those both at the same time. Complementary is two angles that add up to be 90 degrees, and supplementary means they're adding up to be 180, yeah? Okay? Now, I always get those two confused, complementary versus supplementary, so here's how I remember it. C comes before S in the alphabet. 90 comes before 180 numerically. So C goes with 90. Now, this is what Kyle said this morning, okay? Here's an S, right?
Oh my god.
Check this out. I don't know. It kind of makes sense a little bit. That's S. Supplementary starts with S. C is half of it. Ha! Look at that.
That's stupid.
That's
That is
stupid.
So stupid.
So C is half of an S, I guess, whatever. So anyway, 90 is half of 180, C is half of an S, right? It's like whatever. Anyway, so that's how you can remember. 90 is the complementary, 180 is the supplementary. Let's look at the examples here. So they have these two right here. How do I know that angle 1 and angle 2 in that case add up to be 90? How do you know that angle?
There's the square.
Because there's the box in the corner. So angle 1 and angle 2 are complementary. Angle 1 and angle 2 are also what?
What?
What are angle 1 and angle 2 also? They're complementary. They add up to be 90, but they're also right next to each other. They're also adjacent, right?
Can I have mine?
They're also adjacent. Give them a pencil back. They're also adjacent. They're sharing a side, right? Okay. Now, A and B over here, those are complementary because they add up to be 90, right? 65 plus 25 is 90. But are they adjacent?
No.
Not adjacent, right? They do not share a side and a vertex. So they're not adjacent. They're not right next to each other. Make sense? Okay, let's go down to these. These are examples of supplementary. So this one right here, they're saying angle 3 and angle 4 are supplementary. They add up to be 180. They are also what? They're also adjacent because they share a vertex and a side. They share this side, right? Adjacent, but they are also what else? They are adjacent and what else?
Linear.
They're a linear pair. Right? They are also adjacent to each other and they're a linear pair. They're making a straight line, right? Make sense?
Yeah.
Okay. Now, these two examples over here, P and Q, these guys, are those two supplementary?
No.
Yeah.
Yeah, they add up to be 180, but are they adjacent?
No.
Not adjacent and not linear pair. Right? Does that make sense? They're not together, so they're not adjacent. They're not a linear pair. Make sense? Okay? This last one down here says angle 1 and angle 2. Right here. This angle right here. Angle 1 is this guy. Angle 2 is this guy. They are a linear pair. What else are they?
Supplementary.
No, they're complementary.
No, they're supplementary. Supplementary is adding up to be 180, right?
Adjacent.
Oh.
And they're adjacent. They're supplementary and adjacent. All right, now, this concept, will every single linear pair be supplementary?
No.
Yes.
If they make a
Yeah.
straight line, will they always add up to be 180?
Yeah.
Sure, yeah, they will. So this says every linear pair, the angles in a linear pair are supplementary always. Okay, no matter what, if they are forming a straight line, they are going to be 180 degrees. Make sense?
Yeah.
Okay, let's go to the example down below here. We've got three of them. Find the measure of two supplementary angles. Okay, we don't know what those two angles are called, so let's give them a name.
1 and 2.
Angle one, let's use variables, not numbers. I get what you're coming from, but that's just going to confuse us. What? C and D. Okay, so C and D are going to be our angles. You could have called them 1 and 2, but that's going to confuse things here in a minute. Okay, so let's call them C and D. Two supplementary angles. If they're supplementary, what do we know about C and D?
They have to,
They
they
are
have
a
to make
linear
180.
pair. And
C plus D equals 180. Okay, all right, right? Okay.
Yeah.
If the difference of the angles is 18, what does that mean? The difference.
The 1 minus the other.
The one minus the other, C minus D, let's say, is 18. How do we figure out what C and D are? Do you guys remember in algebra we would do like substitution and elimination?
Oh my
Yay.
god.
Yay.
Oh.
Yes.
I literally
Yay.
do this stuff so
If
much.
I add these two equations right now, does one of my variables cancel out?
Yeah.
Yeah, the D does. Okay, what's C plus C?
2C.
2C, and 18 plus 180 is 198. And then
You divide it by 2.
divide by 2. C is 198 divided by 2 is 99 degrees. That's what angle C is. Okay, how do I figure out what angle D is?
You plug C, or you plug 99 in for C, and then you, yeah.
Okay, we know that whatever we're adding to 99 has to be 180, right? Okay, so we subtract 99. What's D have to be? It's 81.
81.
It is. Now, do they have a difference of 18 though? Yeah,
Yeah.
you betcha. Okay. All right, next one. They say find X and Y so that PR and SQ are perpendicular. What does perpendicular mean?
the one.
Right.
Form a 90-degree angle.
Yeah.
Okay, so PR is this guy and SQ is this guy, and they're forming a 90-degree angle. So that means like this is 90, this is 90, this is 90, this is 90. They're forming four 90-degree angles. Yeah?
Is there a name for the box thing? Or is it
You know, I don't know. I
Yeah.
wish there was a name. We should look it up later. We'll look it up. Okay? Okay, so we want to solve for x and y. I have 2x here, and I have 5x plus 6 here, and then I have 4y minus 2 here. Let's figure out a strategy. What do we want to do?
90.
2x?
2x plus.
Yeah, so
5x
these two
plus
angles
60.
together, I would add together to make 90, right? Okay, so 2x plus 5x plus 6 equals 90, which you said right is 7x plus, so let's minus the 6 over. 7x equals 84.
Yeah, divided by 7.
Divide by 7, x is like 12. Yeah, okay. Then we can do the same thing for the y. I'm going to do the y over here on this side. But this one we don't have to add anything together. We just have 4y minus 2 has to be equal to 90, right?
Minus the 2.
Okay, add the 2 over. Yep, add the 2. 4y equals 92.
Divided by 4.
Divide by 4, so y is, what's 9 divided by 2? Or 9 divided by 4?
Is it not
2 with 1 left over. 12 divided by 4 is?
You literally could have plugged it. Okay.
Yeah. Make sense?
Wouldn't it be 24 though? Because if you plug that into 2x. I don't know. If you plug x into the 2x instead of the 5x plus 6.
We're not plugging it in anywhere. We're solving for this guy right here. 4y minus 2. So we didn't have to plug in anywhere. Because it just says find x and y. Yep. Okay, good? All right, moving on. Are we ready for the last one?
Yeah.
Okay, let's talk about this diagram before we do anything. Before we answer any questions. Let's talk about, so G is here, H is here, J is here. Ready?
Yeah.
What does this mean? What does that little mark mean?
Wait.
The middle.
This guy right here.
No, what's it called? It's congruent.
That means like this length right here is going to be exactly the same as this length right here because those are like two little tick marks. Do you see that?
Yeah.
Okay, what's some other things that I know?
It's a right angle.
The right angle. So I know that this angle right here is 90 degrees, yeah? Because he's a box. Okay? Yeah. Yeah? Because the box is only going for that part of it, right? It doesn't go all the way down. It's not like this is the box, right? Do you see that? There's a difference. So this is the 90-degree angle. Okay, there's one other marking on there, and it is this thing. What does that mean?
They're the same angle.
This is the same measure as that, whatever those are, right? Okay, so if one of them's 20 degrees, the other one's also 20 degrees. All right, so let's do some things. So we've got determine whether each statement can be assumed from the figure. So angle KHJ. Let me erase. KHJ. KHJ is this guy right here. That angle. And GHM are complementary. What's complementary mean again? They add up to be 90. Do those two things add up to be 90?
I'm gonna say no.
There's already.
We don't necessarily know that for sure, right?
Yeah.
Okay. So here's the
Yes,
deal.
it does because no, never mind.
If this is 90 degrees, right? This guy's 90 degrees, then these three angles together have to be the other 90, right?
Yeah.
So can this angle right here and this angle right here add up to be 90? No. So that one's false. We're going to say, I don't know. False or no, doesn't matter, whatever. Okay? Does that make sense?
Yeah.
Yeah? Okay, moving on next. GHK. GHK is this angle right here, this one, okay? And JHK, this guy right here, are a linear pair.
Yes.
Are they making a straight line? Yes. This first angle is like three angles together, right? Okay, but yes, they are making a linear pair, just those two, so true. Okay, and the last thing says HL, which is this guy right here, is perpendicular to HM.
Yes.
What does perpendicular mean?
Makes a right angle.
90-degree angle. Is it making a 90-degree angle in that spot?
Yeah.
You betcha, so that's true also, or yes. Makes sense?
Yeah.
Good, happy with that?
Yeah.
All right, everybody say bye, Jalen.
Okay.
Bye.